So I've been meaning for a good while to do a video on what we call the lightning dress. It was a collaboration between a whole bunch of people in FabLab Limerick, maker group, fashion designers, electronic engineers, software engineers, ceramicists, a whole bunch of people. And we all got together, went through, weeks and weeks of design and implementation and, prototyping and design and so on, and came up with this. Now the thing about it is it has 900 LEDs, and a lot of dresses and a lot of fashion we see is quite bulky, so we wanted to make something that was quite snug and tight fitting and managed to hide the LEDs in a kind of a more elegant way than what you'd see in the traditional stuff you'd see. So all the battery packs hidden in there. We'll go into that in detail later. So let's have a look at it in action. So here's the dress in action. All the light in the room is created just by the dress itself. There's quite a lot of light off it. And when I do the sensor at the back, which is magnetic, you get the lightning effect. I'll do that again. So let's have a closer look. So we've got all the arrays of LEDs are mapped onto a 2D plane. So they're all in sync, so they're all playing a pattern from the Edison. So they feed through to each other, and the patterns all feed through each other. At the back we have computer, power pack, all of that. So you can see the shape follows the form. So here we've got Edison, fade candies, 7 batteries. So we linked it into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 7 batteries, 1 for the fade candies, 2 fade candies, 1 for the Edison, and 1 for a USB hub. And it all fits nicely, nice, and you can see it's nice and flat, reasonably flat. So the wiring inside is an absolute mess. We can take a look at that. So let's just have another quick look. So at a distance, in a club, I think it'd be fairly crazy. Especially when you turn on the lightning strikes. So if we now have the dress on face down, we can just have done a couple of clasps that keep it attached there. So I've just taken those off because that keeps it nice and close to the back. So now here's where it gets messy. So told you. So we've got a whole bunch of batteries. We've got, so the main data and power down to the LEDs are here. So there's 6 channels on each side. So we have data and power. So we have sets of 3s, ground, 5 volts, and data, and sets of 3s by 6 going down into all the channels on the dress itself. So there's 12 channels in total. So the 12 channels are fed by 6 batteries. A battery feeds 2 channels. There's around about, I don't know, I can't remember, say 900 divided by 6, whatever, 150 LEDs per channel. But it's not always 150, it might be 120. So looking a bit closer at the contents of the backpack, you can see it's just slits with little pockets, and they sit into the pockets when they're actually hanging down. So we have 1, 2, 3, 4, 5, 6, 7 batteries. We have the 2 fade candies are in this compartment here. USB hub is in that because we need a USB hub to talk from the Edison. This is 1 USB port to 2 fade candies. And then we have the Edison here, which you can see the green LEDs of the Edison, an x86 based single board computer that drives everything, including the pattern generation for the LEDs. That talks to the fade candy, which actually generates the data signals for the LEDs, and it all fits nicely in there. We also have down on the bottom here, we've got a magnetic sensor, magnetic read switch, which we can use to trigger the lightning effect. We can also log in via Wi-Fi, of course, and change the patterns that way. There's a couple of preset patterns. I'd have to grab the ESS ID. I can't actually remember what it is at the moment. But this is just really to give you an idea of what's involved. If I was to take down the zip and give you an idea of what's inside, again, lots more wires, and yeah, it gets pretty messy. Give an example there of what's going on. Yeah, you can see there's lots of wires, but when it's all zipped up and closed, it's nice and tidy. And then when we put that the proper way down, cover it up and tie that on there, and the other side on there, and we can just place it back on its there we go. We have to turn around. That's the back. So again, the lights, that's what you get again. Okay, of course I forgot to mention, this is the battery charger where we have all our batteries, spare batteries charging. You know, all individual chargers charging the LiPos, which we just slot in there. Driven by, of course, very chunky power supply. So there you have it. So there's the backpack, the inside of the backpack. Just turn it over, show the outside of the backpack. Let me turn it over, show you the messy wires, Edison, and the 2 main data cables, really the spinal column of the dress. And let's take a look at the inside. So that's what it looks like on the inside. So we have the 2 main channels coming in here, feeding into all the individual channels on one side. That's actually the back. If I just close it up like that, so we'll see that the two main data feeds and power feeds come in. So if I open it up, that's what we get. So we have, say, take an example panel. So this one is the largest panel, so there's 3 channels involved. So we feed in one, so the line comes down, it loops down to the next one and back up again. Same with this first channel, it comes in, goes down, loops to the second one, and loops to the third one. So those 3 strips are actually one strip, but the pixels are all mapped in a way that the pattern generator knows where they are in 2D space to generate a consistent pattern. And likewise, that panel, again, that channel is mapped to just beside this one, and then again the third channel, so they're all mapped together to form a square, a rectangle. And again, similarly with this, plus a triangle here, shoulder patches, they have a set of Arab channel there and the channel there in the shoulders. And we have the diamond in the middle, which again it's just a simple one panel coming down along there and down to there. So the design we used was we soldered just 2.54mm pitch pins onto the end of each strip and used little DuPont connectors and flexible silicone wire that's nice and flexible and soft. It will take lots of bending and lots of abuse. We didn't use solder because solder might tend to break at the end points of the strips. So we thought with the DuPont connectors we could just whip them off and replace them if needed rather than resoldering. It does require you to have a crimp tool handy though. But there you go. So I'm just gonna pop it back together now. Hope it still works. And there we have it back together. Seems to be still working okay. Fairly fragile, but it's put up with a lot of abuse over the last couple of years since we built it. Let's just turn it off once more. Turn off the lights, Fab. Okay. So I hooked up the laptop. Try a few different patterns. So that's a nice slow one. Kind of makes use of a lot of pixels. Could be up to 30 amps running through that, 5 volts. When all lights are on, solid white. They're all RGB, so it can display any color. So another pattern, let me see, what's that one? That's more a kind of a spot light that's moving around within the dress. So it's just panning around the place. But again, you can see that, you know, the panels are all mapped onto 2D space, so when that spot is moving around, it's actually coherent. And another one, which is I think the one we're using the other parts of the video. Yeah. And the lightning effect, bang. And again, bang. Yeah, I think I have one more. Yeah. They're kind of flashy. Yeah, I mean, we only did 4 patterns, but 4 or 5 patterns, but you could do a hell of a lot more. Anyway, hope you enjoyed the video.